Welcome everyone to Statistics Without Tears video series. In this chapter, we talk about comparing two groups. We want to compare two groups with some t-tests and similar non-parametric tests. So in this first video series, we gonna cover one sample t-test, and in the subsequent recordings, I am going to cover independent samples t-test, the non-parametric Mann-Whitney U-test or U-test, and we're gonna learn to apply paired samples t-test. And after that, we're gonna use the paired t-test in order to check reliability of the research instruments. And finally, in lesson number 6, we're gonna learn non-parametric Wilcoxon test for two related samples. So as a snapshot, these are core components or core takeaways from this chapter 9. So let's go straight to the first lesson, lesson 9.1, one sample t-test. So why one sample t-test? You could ask this question. What kind of research questions does a one sample t-test aims to address, aim to answer? Yep, the following questions are appropriate for a researcher to employ to perform a one sample t-test. Okay, I have provided for your reference 3 different research questions that require the use of one sample t-test. Okay, the first research question looks like this. Is the mean IL score of my class significantly different from the presumed population mean of 6.5? You can see in this research question, the researcher tries to compare the mean score of his class or his sample with the hypothetical population mean. So this kind of research question is going to be handled by one sample t-test. It's, in other words, one sample t-test is designed to answer such research question. The second research question provided for your consideration or deepen understanding of the nature of one sample t-test is this question. Is the mean SAT math score significantly different from the presumed population mean of 500? And the third and final question is the mean English proficiency test score of Master of Arts Generation 22 significantly different from the presumed population mean of 30? So you can see in all research questions, you can see a number like IL score 6.5. This is the overall score. This is the population parameter 500, and this is the population mean of 30. So the next question is, where do they come from? Where does the overall IL score of 6.5 come from? Where does a score of SAT Math 500 come from? Where does a population mean score of 30 on EPT come from? There's a long story to it, and I want to tell that story a little bit. For example, a score of 6.5 is observe. Okay, scientists, researchers, scholars observe when students in a country take IEL test years and after years and after year, and they construct the normal curve. It's clear that the mean score of the students population who have taken the IEL test over the years is 6.5. So that's the mean score. That's observed. Okay, it's a 6.5. So 6.5 is the mean, is the center score in the normal curve. So it's become a theory. It become a principle. It becomes like a fact in the population. So that answer the question, where do these numbers come from? Another classic example regarding the population mean is the SAT math score. It has been observed that most students, okay, on average, students who have taken SAT math, their average score is 500 with a standard deviation of 100. So it becomes standardized. It's become like factual or principle or theory in real life in the population, and this is basically the same. So again, in this slide number 3, we talk about the kinds of research questions that a one sample t-test is designed to analyze. So some more concepts. We use one sample t-test to compare a sample mean with a hypothesized population mean to see if your sample is significantly different from the hypothesized population mean. So in short, there are two means in this context. Your sample mean, you compare your sample means with the population mean in order to see if it is statistically different from the population mean. Another important concept to take away is about the two assumptions of one sample t-test. There are two main assumptions of this test. The first assumption is the dependent variable is normal in the population. For example, you want to compare the IELTS score of your class with the hypothesized population mean score. Okay, IELTS score of the population. In this context, your samples IELTS score have to be normal, have to be approximately normal. Okay, and the second assumption is the data are independent. In other words, the scores of one student or one participant are not dependent on the scores of the others. So the second assumption is it should be okay, should be should not be a concern, because you collect data from your class, and each student and each student basically took the test and was provided with the test score. So we go to SPSS in order to analyze the data. It's very easy. When you go to SPSS, step number one is to go to analyze. Step number two is to go to compare means. It's very easy. Step number three is to go to one sample t-test. No worry, everyone. We have real data to demonstrate for demo. Not a problem. We're gonna go to SPSS as soon as possible. So step one, analyze. Step two, compare means. Step three, one sample t-test. Step four, you enter 500. This is the test value that you want to compare your sample mean with. You enter 500 or 6.5 or 30 in the test value box, depending on your research question. And the last step is to click on OK, and you're gonna wait and see the result. Okay, so now it's time for us to break a little bit, a moment of silence, so that I can switch to SPS data, so that we can run or perform one sample two tests together. Okay, don't forget everyone. Analyze, compare means, one sample t-test, and then we're gonna enter the test value. Okay, test value here refer to the hypothesized population mean, and we're gonna click OK. Okay, a moment of silence. Okay, I'm going to switch the screen to get to the data. Okay, everyone. A moment of silence is over. Right now, we want to answer this research question. Is the EPT score of the respondents in my research significantly different from the hypothesized population EPT mean score of 30? Okay, we're gonna go to analyze. We're gonna go to compare means, because we are going to compare two means. And then we go to one sample t-test. We go to one sample t-test, and we're gonna move EPT score to the test variable box. And so easy, we're gonna click OK. And this is the output. The output, you see the first table and the second table. I want to take a moment in order to switch to the PowerPoint slides, because the visuals, are bigger over there. A moment of silence again. So again, everyone, this is what these are the results from SPSS. So the first table we ask, as you can see, is this is the variable EPT score of the MA generation 2. There are 37 students or respondents in this study, and this is the average score of our sample. Okay, 32.22 out of 50. Okay, the total score of the test, or the test is 50, so 32.22. So second table, you see the test value. This is the hypothesized population mean. So we compare the mean score of the sample with the population mean here. And more interesting results are located in this highlighted piece. You can see this is a t-value. Okay, one sample t-test t-value, degree of freedom, and the significance and two-tail. Okay, this is the p or probability value. So this is a call out box that explains what these numbers mean. So the most important numbers perhaps is the p-value or probability value. So the t-test is not significant. It is not significant because p-value is greater than 5%. P-value have to be less than 5% in order for us to reject the null hypothesis. Okay, the null hypothesis in this research is the sample E/T mean score does not significantly differ from the population mean, but that is the hypothesis, and we have no evidence. Okay, there is no evidence for us to reject the null hypothesis. So the null hypothesis is not rejected. It's not rejected. So, in other words, if you go to the mean difference between the two means, so our sample average mean is a little bit higher. It's 2.22 points higher than the hypothesized population means. Okay, so the difference is quite small. In fact, it's quite small. A total score of 50 over 50, and our sample performs a little bit better than the population. On average, the population perform at 30. Okay, they score an average of 30. So perhaps that explain why there's no difference between the two means. Okay, now we go to report writing. That's interesting. Okay, how to construct a paragraph in order to report our research results to the audience. So this is how we do it. Okay, to investigate whether the E/T score of MA G22 students is significantly different from the standardized population mean of 30, one sample t-test was performed. So again, this first sentence gives us two pieces of fundamentals. Okay, two fundamentals. And the first part talks about the research hypothesis or research objective, and the second part talks about what kind of statistic we are performing in order to answer the research question. So we shall continue. The MA generation 22 E/T mean score of 32.22 out of the total score of 50 was not significantly different from the hypothesized population mean of 30. And then T, and then degree of freedom, T equals 1.68, P equals 0.101. So in conclusion, our research does not produce a significant difference between the two means, and this is exciting. One sample t-test can uh, can be applied in various ways in order to understand our data, in order to satisfy our research questions or research inquiry, curiosity. So that's it.